Good morning. Welcome to the next lecture. As we are already said that there are several methods to solve a quadratic equation depending upon the specific form of the equation, and accordingly we discussed factoring method, quadratic formula and method of completing squares in the last lectures. See, today we will discuss how to sketch the graph of a quadratic equation. We were already said that a quadratic equation is an equation in which the highest power of unknown variable x is 2, which means that the highest power of the variable is 2. So the general form of a quadratic equation, which is having ax square plus bx plus c is equal to 0, where a, b, c are the constant and a is not equal to 0. So if you go for graphing the quadratic equation, then it is generally called a parabola. And a parabola is a symmetrical curve that can either open upward or downward depending upon the sign of the quadratic equation, that is here the sign of A. So depending upon the sign of A, we may have the different shape for the parabola, which may be open upward or downward. Now, in order to sketch the quadratic equation, we have to follow certain stepwise procedure. See, we will discuss here these procedures to sketch or to draw the quadratic equation. See, first one, we have to determine the shape of graph. Then after that, see, we will find the intercept terms, that means x-intercept and y-intercepts. Then we will go for finding the line of symmetry and the vertex point. The line of symmetry and vertex point, and accordingly we will draw the axis and tick all the point which we are already estimated earlier, and then we will go for drawing the parabola by connecting all the points and label the graphs. So we will discuss each steps in detail so that it can be easily draw the graph of a quadratic equation. The first step is that we have to decide the shape of a parabola. See, parabola have two orientation, which may be concave up and concave down. The orientation of parabola can be found from its equation, and the direction of parabola, that may be upward or downward, is entirely determined by the sign of coefficient of A. And if here ax square plus bx is equal to 0, this is the general equation of a quadratic equation, and the shape of this parabola is entirely depending upon what is the sign of the coefficient of A. See, if A is greater than 0, then the parabola open upward. And if A is less than 0, then parabola open downward. So we can see this is the upward, concave up parabola, where we are assuming that A is greater than 0. That means if our coefficient A is greater than 0, then parabola will be look like concave up. Similarly, if our coefficient A is less than 0, then the parabola will be look like this. See, it will be a concave down. It will be a concave down. So depending upon the sign of coefficient A, the shape of parabola or direction of parabola is determined. Now let us consider if y is equal to x square, which is starting from x square, then the parabola will be concave, it is concave up, because here x square, the coefficient is equal to 1, which is greater than 0. So similarly, if you are considering y is equal to minus x square, our quadratic equation is starting from minus x square, then the parabola will be concave down, because the coefficient A in the case of minus x square will be less than 0. So we don't include in the case of A is equal to 0. We are considering here A is greater than 0 or A is less than 0. What happens if A is equal to 0? then the quadratic equation reduce it a linear format, or it will become a linear function, because if a is 0, then ax square term will become 0, then what is remaining, it is become a linear equation, that is bx plus c is equal to 0. Now, after determining the shape of parabola, the next step is to find out the intercept terms of the parabola. See, before sketching the parabola, we want to draw the scale on x and y axis. Then we have to find x and y intercept term. So determining y intercept is crucial step, especially in drawing or sketching the graph of a quadratic equation. And the y intercept is nothing but it is the point where the graph intersect y axis, and it generally occur when x is equal to 0. So when you are putting x is equal to 0 in the quadratic equation and solve for y, then whatever the result is coming, which is generally known as it is y intercept term. See, for example, y is equal to x square minus 5x plus 6 is equal to 0. Then here the y intercept can be found by substituting x is equal to 0. See, if you go for substituting x is equal to 0 here, then x square term will become 0, minus 5 into x, that is 0, that is this term is also become 0, then plus 6. So it will become y is equal to 6. So we can say that if you go for substituting x is equal to 0, then our y intercept term will become 6. That's why the y intercept is 0 and 6, where when x is equal to 0, the y is 6. Similarly, we can find the x intercept term, which are the point at which the graph of a function intersect the x-axis. So in order to find out the x-intercept of a quadratic function, we want to find out the roots of a quadratic equation, where the graph intersect the x-axis. And mathematically we can say that the x-intercepts are the solution to the quadratic equation, that is f of x is equal to 0, or we are assuming that y is equal to 0. So consider one example so that it will be clear. Y is equal to x square minus x minus 2. So here we want to solve the equation by assuming y is equal to 0. So by assuming y is equal to 0, then what happened? The term x square minus x minus 2 is equal to 0. So we can find here the value of x, for we want to solve the following this particular linear equation. So by using the factorization method, we can write what are the various factors of x square minus x minus 2. See, it will be x plus 1 x minus 2, which is equal to 0. So here by using the factorization method, you can find these factors. Now we can solve this x plus 1 into x minus 2 equal to 0 separately. So it will become x plus 1 is equal to 0. Therefore x is equal to minus 1. Similarly, x minus 2 is equal to 0, where x is equal to 2. So here the x value, which is nothing but it is the x-intercept terms. So here the x-intercept terms are 2. It is touching the x-axis into 2 points, that is 1 minus 1 when y is equal to 0, and another point is it is 2 when y is equal to 0. So therefore the x-intercept term is minus 1, 0, 2 and 0. After finding the intercept term, the next step, see, the number of x-intercept and their nature is entirely depending upon the discriminant of the quadratic equation. And we know that the discriminant is given by, that is b square minus 4ac. b square minus 4ac, where a, b, c are the coefficients of the quadratic equation. See, if the discriminant is positive, that is b square minus 4ac is greater than 0, then the quadratic equation that have two distinct real roots, and parabola pass through 2 points of the x-axis. Here the parabola pass through 2 points at x-axis. This is one is here and another one is here. Now let us imagine that what happen if the discriminant is equal to 0, that is b square minus 4ac is equal to 0. Then the quadratic equation have only one real root, and the parabola touch the x-axis only at a one point. So here parabola touch the x-axis at a one point. Similarly, see if the discriminant is negative, that means b square minus 4ac is less than 0. Then the quadratic equation has two complex conjugate roots. So geometrically, if you represent this, then this corresponding to the graph quadratic function not intersect. Here it is not touching into the x-axis in the real number system. So in this case, that is b square minus 4ac is less than 0, then parabola do not touch the x-axis. Then the next step is to find the vertex. The vertex point. See, the vertex is nothing but the highest or lowest, that means the maximum or minimum point of the parabola is generally called is a vertex. And it is entirely depending upon the direction of parabola. If parabola is concave up, just like this, then the vertex have, it is minimum point. Vertex have minimum point. And if the parabola is concave down, then the vertex have the maximum point. So it's entirely depending upon, the direction of parabola, whether it is a maximum or minimum. So here, the direction of the parabola upward and downward is determined by the sign of the coefficient of a. And if a is greater than 0, then parabola open upward, and if coefficient a is less than 0, then parabola shows a open downward, or it is concave down. But here the question arises, how we can know the vertex point, or that is maximum or minimum point of a parabola? See, it can be found at the point of the line of symmetry. See, the next step is we want to find out the line of symmetry. See, what actually the line of symmetry means? The line of symmetry for a quadratic function is a vertical line that passes through the vertex of parabola, dividing the parabola into two symmetric halves. So the equation of the line symmetry can be determined using the x coordinates of the vertex. See here, this is the line of parabola when we have a concave up curve, and this is passed through the vertex minimum point. So this is the line, that is line of symmetry. Similarly, in the case of a concave down, see, this is the line of symmetry which is passes through the maximum point. So in this way we can find the line of symmetry. So here the vertex or point on the parabola is also lies on the axis of symmetry, and the vertical line that passes through the vertex. It is passes through the vertex, and this line is actually divide the parabola into two symmetric halves. Now, using the fact that the parabola is a symmetric, we can determine the equation or formula for vertical line of the symmetry using x-intercept term. See, for that we want to find out x value midway between x-intercept by taking an average. It will be clear. See, by using our quadratic formula, see, the x-intercept can be found here. X is equal to, we know this is the quadratic formula, minus b plus or minus under root b square minus 4ac divided by 2a. Now we have two value for x. One is minus b plus and second one is minus b minus. So we are writing it separately. See, minus b plus under root b square minus 4ac divided by 2a and minus b minus under root b square minus 4ac divided by 2a. Now we are going to find average of these two values. So we are adding up these two values and dividing with 2 so that we will get the average. So x is equal to minus b plus under root b square minus 4ac divided by 2a plus minus b minus, one is here plus and here it is minus under root b square minus 4ac divided by 2a whole divided by 2 so that we will get a average. Now here see, plus under root b square minus 4ac minus root b square minus 4ac. So here these two terms will be cancelled out. So I am cancelling these two terms. What is remaining here? X is equal to minus b divided by 2a minus b divided by 2a all divided by 2. I am writing here separately, that is x is equal to minus b divided by 2a plus minus b divided by 2a divided by 2. So now here the denominator have the same value, so we are taking it is 2a once and taking minus b plus minus b, it will become minus 2b divided by 2. Now see here, I am going to take the cross multiplication because here divided by 2, so I am going to take the cross multiplication, so it will become 1 by 2. So here we can cancel down the minus 2 and 2 here, so it will become only minus b. 2 and 2 will be cancelled out, so it will be minus b divided by 2a. And this is nothing but, see, this x is equal to minus b divided by 2a is the line of symmetry, which will be determined by using this particular formula, or which can be find out by using this particular formula. So in order to find out the vertex point, see, this is the line of symmetry. So we want to find out the vertex point, then we have to substitute the value of x is equal to minus b divided by 2a in the given function, so that we will get the vertex point. So vertex point will be happen at the line of symmetry, that is minus b divided by 2a. And what is the vertex value? If you go for substituting x is equal to minus b divided by 2a in the given function, then it will be the vertex value. So understanding the vertex is an important because it gives the information about the turning point of the parabola. If the parabola is open upward, then of course the vertex is minimum point, and if the parabola is open downward, then the vertex having the minimum point. So after finding all these steps, whatever we are discussed now, we can directly proceed to draw the axis and tick all these points, and finally draw the parabola by connecting all the points and label the graph. And I hope it is clear about all these steps. We will go for taking some examples so that it will be more clear. See, consider an example, that is, give a sketch of graph of following quadratic equation, that is f of x is equal to minus x square minus 2x plus 3. So we want to find out the graph of a quadratic equation given by f of x is equal to minus x square minus 2x plus 3. So here the identity are, first we have to find the shape of parabola, which is actually determined by the coefficient of a, which will be determined the coefficient of a. So here the coefficient of a is equal to minus 1, coefficient of b is equal to minus 2, c is equal to 3. So the first step is to decide the shape of parabola, whether it is concave up or concave down. So we discussed in the earlier as well, the direction of parabola, whether it is upward or downward, is entirely determined by the sign of coefficient of x square, that is a. So if a is equal to greater than 0, then the parabola open upward, and if a is equal to less than 0, then the parabola open downward. So in this case, what we can say, a is equal to minus 1. Here the coefficient of x square is equal to minus 1, which means that a is equal to less than 0. So here in this case, the parabola open downward. The parabola will be open downward. So it will be look like this type. It is a open downward. Now, after finalizing the shape of parabola, then the second step is to determine the intercept terms of the parabola. That means x-intercept and y-intercept. See, the y-intercept is the point where the graph intersect the y-axis, and it is occur when x is equal to 0. So we are putting x is equal to 0, then find the value of f of 0. Then it will become, see here in the given function we are going to put the x is equal to 0, then f of 0 is equal to minus 0 square minus 2 into 0 plus 3. Then all these terms will become 0, then f of 0 is equal to plus 3, which is equal to 3. So the y-intercept term here, it is 0 and 3, which means that when x is equal to 0, then the value of y is equal to 3, and this is considered as a y-intercept term. After finding the y-intercept term, we have to determine the x-intercept term, and x-intercept term is the point at which the graph intersect x-axis. So here the x-intercepts are the solution to the equation of f of x, putting f of x is equal to 0 or putting y is equal to 0. So in our example, see f of x is equal to minus x square minus 2x plus 3. Now we are equating with this particular equation, this particular function to 0. Then 0 is equal to minus x square minus 2x plus 3. We are going to find the solution of this particular quadratic equation, or we are going to find the roots of this particular equation. For example, we are using the symbol factoring method, so that the factors here, that means the product should be 3 and the sum should be minus 2. And here the factors will be, see, x plus 3 and x minus 1, which is equal to 0. These are the two factors. Now we are solving for 0, then isolating the x variable, then we can say that x is equal to minus 3 and x is equal to 1. Which means that, see, we have two values for x, which means the x-intercept, that means parabola touches the x-axis into 2 points, one is minus 3 and another one is x is equal to 1. So here the discriminant, see, b square minus 4ac is greater than 0, because if you go for it, then it is minus 2 square minus 4 into minus 1 into 3, which is 16, which means it is greater than 0. So therefore, the quadratic equation here, we have two distinct real roots, that is here minus 3 and 1. It means the parabola passed through the 2 points at the x-axis, and these 2 points are x-intercept, and we can say that it is minus 3, 0, 1, 0. That means when x is equal to minus 3, when y is equal to 0, and x is equal to 1 when y is equal to 0. So this is the x-intercept term. So we estimated the y-intercept term and x-intercept term, and we also know what is the shape of the parabola. Now we can go for calculating, determining the line of symmetry. See, the line of symmetry, see, it is the given example, power of the highest point of the parabola is called, it is the vertex, because here it is minus x square, it is minus, the coefficient of a is equal to minus 1, which is less than 0, so it will be concave down. So we want to find out the highest point of the parabola here. So the line of symmetry for the quadratic function is a vertical line that passes through the vertex of the parabola, and it is dividing into two symmetric halves. Therefore, the equation of the line of symmetry can be determined by using the equation, that is x is equal to minus b divided by 2a. And we want to find out the value of x here, because we know here b is equal to minus 2. So we are going to substitute here b term, and a is equal to minus 1. So substituting here, minus into b, which is equal to minus 2, divided by 2 into a, which is equal to minus 1. So if you go for solving it, then minus minus will become plus, so it is 2. 2 into minus 1, which is equal to minus 2. So it is 2 divided by minus 2, which is equal to minus 1. So the vertical line of symmetry, is happen at x is equal to minus 1. Then after finding the line of symmetry, we want to determine the vertex point, because at the line of symmetry the vertex will be happen. So we are going to substitute, or we are going to find the vertex point by substituting the value of x is equal to minus 1 in the given equation. So here our given equation of function is equal to minus x square minus 2x plus 3. Here we are substituting x is equal to minus b divided by 2a, which is equal to minus 1 in a given equation. So our given equation is equal to minus x square minus 2x plus 3. So here x is equal to minus 1. So minus 1 square minus 2 into minus 1 plus 3. So it will become, see, it is 4. If you go for simplifying it, then you will get the 4. So f of minus 1 is equal to 4. So the vertex point here, we can say that it is minus 1. When x is equal to minus 1, then the parabola will have the maximum point, that is y is equal to 4. So after finding all these steps, see, now we can proceed to draw the axis and tick all the point, and finally we draw the parabola by connecting the all points. So we are just recalling whatever we are calculated here. See, we know the parabola is open downward. As per our example, it is a is equal to minus 1. So, it is a is less than 0. The parabola is open downward. Y-intercept term is calculated. X-intercept term also it is estimated here. The line of symmetry is happen at x is equal to minus 1 and vertex point is, when x is equal to minus 1, y is equal to 4. So, now we can go for plotting all these points in the graph. See, we know the parabola is downward, it is open downward. Y-intercept term which is 0, 3. So, when x is equal to 0, then y is equal to 3. So, this is the point I am marking here. Then x-intercept term that is minus 3, 0 and 1, 0. See, this is minus 3 here. When y is equal to 0, then x is equal to 1. That means this particular parabola is crossing the x-axis at a 2 point, that is minus 3 and 1. Then we have to draw the line of symmetry. See, line of symmetry will happen when x is equal to minus 1. So, x is equal to minus 1 is here. So, this is the line of symmetry. See, I am drawing here, this is the line of symmetry. So, the maximum point will be happen on this particular line. And what is the maximum value? That is vertex point is 4. So, here the vertex point is equal to at minus 1, it is 4. So, now we can join all these plots or all these points, then you will get, a parabola. See, it is open downward. So, this is the graph of a quadratic equation which we are already given. So, in this way we can draw the graph of a quadratic function. Now, let us consider another one. We want to sketch the graph of a following function, that is f of x is equal to x square minus 4x plus 3. See, from our equation, first step we want to finalize what is the shape of parabola by looking at the coefficient of, sign of the coefficient of a, that is coefficient of x square. So, here x square coefficient is equal to 1. So, which means that a is greater than 0. Then the parabola is open upward. So, we are decided here the shape of parabola, whether it is concave up or concave down. See here, a is equal to 1, which means that a is greater than 0. Therefore, we can say that parabola is open upward. Now, after that, so it will be look like this. It will be open upward. It will be look like this type of parabola. Now, the next step is to determine the intercept terms of the parabola. So, here we want to determine what is y-intercept term and x-intercept terms. See, to find the y-intercept term, we are assuming x is equal to 0 and then we are putting finding f of 0. That means by putting x is equal to 0 on the given equation and then solve for y. Then it will be, see, x square, that is 0 square minus 4 into 0 plus 3. So, all these terms will become 0. Then what is remaining? Y is equal to 3. So, the y-intercept term, that is when x is equal to 0, then y is equal to 3. After finding the y-intercept term, the next step is to find out the x-intercept term, and which is the point at which the graph intersect the x-axis. So, the x-intercept term are the solution for the given equation, that is x square minus 4x plus 3. So, we have to determine the x-intercept term by assuming f of x is equal to 0. So, it will be, see, x square minus 4x plus 3 is equal to 0. Now, we want to solve this particular equation by using factoring method. We want to find out two numbers whose product is equal to 3 and the sum is equal to minus 4. So, it will be minus 3 and minus 1. So, I am rewriting this term by using its factors, that is x minus 3 and x minus 1, which is equal to 0. Now, from this given equation, we can find the value of x by solving for the concerned variable. Then here x is equal to 3 and x is equal to 1. So, here the discriminant, if you go for calculating the discriminant, see, b square minus 4ac, which is also greater than 0. That means it is minus 4 square minus 4 into 1 into 3, which is equal to 4, which means that the discriminant is positive. Therefore, the quadratic equation have two distinct real roots, which means the parabola pass through the 2 points at the x-axis. See here, one is at x is equal to 3 and another one is x is equal to 1. Therefore, our x-intercept terms are 3, 0 and 1, 0, which means that the value of x is equal to 3 when y is equal to 0 and 1 when y is equal to 0. Now, after finding the intercept term, the next step is to find or determine the line of symmetry and the vertex point. See here, the line of symmetry can be determined using the x coordinate of the vertex with the given equation, that is x square minus 4x plus 3. So here the equation for calculating the line of symmetry, x is equal to minus b divided by 2a. Here a is equal to 1, b is equal to minus 4. Now we are going to substitute here minus into minus 4 divided by 2 into 1. So this minus will become plus. So it is 4 divided by 2, which is equal to 2. So the line of symmetry, that means the function will reach to the minimum point when x is equal to 2. When x is equal to 2. But we don't know what is the value of the minimum point. So for that, we have to find out the vertex point or vertex value. So in order to find out the vertex point, substitute the x is equal to minus b by 2a. That means x is equal to 2 on the given equation. That is, we want to find out f of 2. f of 2 we want to find out. So our function is x square minus 4x plus 3. Now we are going to find out f of 2 because x is equal to 2 we are assumed. So here f of 2 is equal to, substituting x is equal to 2, it is 2 square minus 4 into 2 plus 3. So if you simplify it, then f of 2 is equal to minus 1. So here the vertex points are, see, vertex point is when x is equal to 2, then the vertex point, that is minimum point, is equal to minus 1. So now we are followed all these steps and found these various points. Now we can proceed to draw the axis and ticking all the points, and finally we can draw the parabola by connecting all the points and label the graph. See here, we can recall what are the various points we are calculated. Our given equation, a is equal to 1, therefore a is greater than 0, the parabola is upward, open upward. Then y-intercept term, that is 0 and 3. X-intercept term 3, 0 and 1, 0. Line of symmetry, that is x is equal to 2, that is line of symmetry will be happen at the x is equal to 2. Then at the x is equal to 2, then vertex point is equal to minus 1. Now we can go for draw this particular quadratic function. See, by putting all these points, we know parabola is open upward. So it will be look like this, upward, it is U-shaped curve. And the y-intercept term, see here we are going to mark, it is 0, 3. So it is y-intercept is 0, 3. So when x is equal to 0, y is equal to 3. Then we are marking the x-intercept term, that is 3, 0. When y is equal to 0, then x is equal to 1 and x is equal to 3. So here in the 2 points, the parabola is crossing the x-axis. Then the next we will point out the line of symmetry, which is happen when x is equal to 2. So it will be happen on this particular line. So the line of symmetry is here. This is passed through this particular point, that is x is equal to 2. And then we want to find out the vertex point. See, vertex point, that is when x is equal to 2, then vertex point is happen at minus 1. So minus 1 is here. Now we can join all these points. Then we will get the parabola, that is, it is open upward. It is open upward. So in this way, we can draw or sketch the function, that is quadratic function. So let me conclude here. Today we have discussed how to draw the graph of a quadratic equation. We followed a stepwise procedures to sketch the quadratic function. Firstly, we defined or determined the shape of graph. Then we found the y-intercept term, x-intercept terms, and then we found the line of symmetry and vertex point. Then we are marked or plotted all these points on a graph, and that graph was finally shaped a parabola. I hope it was clear to you. In the next lecture, we will discuss how to find the maxima or minimum value of a quadratic function. See, by using the method of completing squares, that is one of the application of the method of completing squares, that is we want to find out the maximum or minimum value of a quadratic function. So we will see in the next lecture. Thank you.